or maybe not surprisingly, a lot of rowers are also pretty intelligent. And I think, well, two things. I think that because a lot of rowers come from high prestige schools, you get a lot of smart people. You have to be pretty smart to get into a Harvard or Yale or Brown, Cal, UW. So you get a high concentration of smart people in the sport. But I also think that having some intelligence and you need to have a lot of discipline, determination. You need to be good at doing repetitive tasks well, consistently. And these are all traits that are also common in successful people. So you kind of get a high concentration of people who will achieve future success in rowing as well.
Hello, John. Welcome to the Grand Slam Journey podcast. Happy Wednesday. Really excited to dive into this conversation with you. We have met through a joint community, The Post, which is a community of former athletes built by sport, headed by Christian Ponder, who was also a guest on my podcast. And I have been connecting with few people, found you. Actually, I thought you had a really interesting background in rowing, which is a sport I obviously know nothing about. So I'm curious to learn more. And now are in quite deep technology working around robotics. So maybe we'll dive a little bit how AI and robotics are shaping the future, and obviously your journey from rowing to the deep technical expertise. But before we kick off and get on this podcast journey, anything you want to share before we dive in? John, introduce yourself to the listeners.
My name is John. I'm from New Jersey. Never thought I had the opportunity to do things I've done. And I got really lucky a few times and took advantage of some opportunities that were in front of me. And I think I've had a pretty cool life and nothing that I would have expected that, these would happen.
Yeah, I love that. We chatted a few times before this and I conquer. So I'm curious to dive in and have listeners hear that for themselves. So what was your upbringing like and what led you to finding rowing?
I'm just a typical American guy. Like my dad had done a few different businesses in his life, eventually became a high school teacher when I was, I don't know, probably 5 or 6. And my mom was a nurse for her entire career. She actually just retired this year, though she still works part-time. And I did kind of typical things like, marching bands. I played baseball and, just general school things. And my family was really close. So I was really lucky that almost all my entire family lived within New Jersey, Pennsylvania, Connecticut, New York. So we all lived really close together. So I saw my family all the time when I was a kid. I think the only thing unusual about my childhood was, and it's not that unusual, I was just bullied kind of badly in grammar school, middle school, and into high school. That was really the only thing unusual about it. And for the typical things, like I wore glasses and I was nerdy and I didn't communicate well with other people, like most kind of science-minded people do. And I was overweight when I was younger, which I grew out of, thankfully. But kind of easy targets for people to make fun of you when you're a kid.
You did a few different things. How did you find rowing specifically? Or is there somebody particular who influenced you in trying it out?
Yeah, rowing was never in the cards for me. I went to a Division III school, like all engineering Division III school. And I was in a lunch line one day and the coach's name was Larry Noble at WPI, Worcester Polytechnic Institute. And he came up to me in the lunch line and said, "Hey, you look like you're pretty tall and strong, unlike the rest of these kind of engineer kids that are kind of short and strippy. You should come down to the boathouse because there's going to be pizza tomorrow." And I said, "Well, that's cool. I'm new to college and I don't have any friends." And I was excited just to have some friends and something to do. Like I want to be part of a team and have something to do with my time, because I knew if I didn't, I'd probably just, I don't know what I would do. Probably just go fishing too much. So I went down to the boathouse and I was just putting the novice crew in and started rowing with them. And it's a Division III school, so it wasn't very serious. Like we practiced once a day, which for rowing is nothing. Rowing is a high dedication sport. So that's how it all started. It was just kind of random occurrence.
Actually curious, there's a few different types of rowing. I've only done the concept 2 rower in CrossFit, which I think is challenging enough. Actually, my back doesn't handle rowing anymore, so my rower just sits in the garage and is collecting dust. But it's always interesting to me the synchronization you have to have when you're rowing. And I've seen a few movies, actually can't remember the name, but there's some really good movie that sounded almost similar upbringing like you, somebody who just started rowing and pretty much made it all the way to the world championship. I will see if I can remember the name of the movie. But curious how that is trained and what type of rowing did you do? Was it two or four people?
That's probably Boys in the Boat, probably the movie you're talking about,
Mm.
which is now famous. So in college, almost everybody knows there's two kind of styles of rowing. One's with one oar and one's with two oars. So everybody in the United States, or pretty much everybody, especially if you learn in college, learns with one oar, and that's called sweep rowing. And typically you row in eights and fours, so it's either 8 people or 4 people in a boat in college. I did that through college, and like I was pretty good at it. Like I had all the school records at my school by the time I was done, and like I was a standout at my college, which is just a D3 school. But then what I got really good at was sculling, which is two oars. And in sculling, there are 3 boat classes. There's a single, the double, and the quad. And I got the best at the quad. And the highlight of my career, I was really good at rowing a quad. And my body type lends itself really well to sculling. I have a pretty short torso, long legs, really strong upper body, which are all more geared towards sculling than they are sweep rowing. So I kind of recognized when I was younger that I was never going to make it in sweep rowing. And how I even got a chance to row at a higher level is just by chance. I graduated first in my class, bachelor's and master's from WPI, and I had a job at the time at Siemens. And I wasn't really excited about the job, but it was a job. And I ended up kind of getting pushed out of the job after I graduated. And I thought, well, I saw all these people rowing and I wanted to know what I could actually do because I excelled at my Division 3 school. I wanted to see if I actually had it to go to the higher levels. So I ended up getting a call from USA Rowing that summer to fill a seat at a quad camp, which is sculling. I never sculled seriously. I just kind of did it for fun up to that point. And I ended up going, and turns out I was pretty good at sculling. And I made the under 23 Worlds that summer. And we didn't do very well at Worlds, but from my perspective, I was just amazed to even had a chance to go to that. So that's kind of what started me rowing at a higher level and how I found I was kind of better at sculling. And after that experience, I recognized that I was a lot better at sculling or would be better at sculling than I would be at sweep rowing.
So what are the differences? I'm actually curious for somebody like me. Again, other than the concept two rowers, you described a little bit the body shape. I guess there's different probably body structure that allows you to be better in one versus the other. But I'm guessing there's quite a bit of strategy when you have obviously more people and just following that rhythm. That's always been something quite interesting to me. How do you train that or become great at it?
Rowing is a really simple sport. You can learn almost all of rowing in 1 week. You can
Really?
learn 80% of rowing in 1 week. You can find out if you're gonna make it or not make it in about a month. You're gonna know. It's not a very hard sport. You need to have the physical ability, the mental ability, and the determination to go do it. So to be good at rowing, you need to be large. It's a power dominated sport. So you need to be strong, long legs help, long arms help. And then you need to have the correct genetics to be good at that type of anaerobic and aerobic endurance sport. It's 6 minutes of pain. So you have to be able to sit through 6 minutes of absolute pain to be good at it. And then as you progress, you'll find out where you fit in. So generally, younger people with more fast twitch muscles are better at the larger boats because they go faster. So you're able to move quicker through the water in the larger boats. And the smaller boats take a little bit more experience and skill, and it's a little slower. So generally speaking, older athletes excel in the smaller boats, like the pair, the double, the single. And the single, if you want to do well in the single, you have to be like a physical anomaly. If you're not, you're just not going to make it. Where in the quad and the eight and the double, it's a lot of team stuff. So if you can fit well in a team and you have the right traits, you can do well in a team sport boat.
Going back a little bit, even to your beginning and the journey, you pretty much got recruited by a person that thought, oh, this guy may be strong and might be able to potentially push through pain. Let's see if we can start him on the rower. How did you then even had the audacity to stick with it and continue to push through the pain? It seems like you got pretty good quite quickly. You mentioned again the ability to be able to push through the pain. I'm guessing, and through some of the conversations we had, that's a skill you may have had or had acquired. Share a little bit more about that and just how that trajectory or the start helped you along the journey pretty much all the way to the championship.
Yeah, a lot of it's just luck, to be honest. I happened to be laid off. Like if I had a job that summer, I wouldn't have gone to that camp and I would have been done rowing. And had I started rowing it, or had I gone to a D1 school, there's no way I would have ever got to where I was. I went to a D3 school where I was one of the best or the best on the team. So I could kind of make my own schedule. I could do my engineering, which was more important to me, and still row. And I've kind of was in the best environment. Unknowingly, I was in the best environment for me to get good at rowing and still pursue engineering, which was really what I want to do with my life. And then things just happened to fall into place. And I remember there was a point in my career where I started a PhD at WPI, my undergrad institution, and I wasn't happy with it. I'm not really sure why I wasn't happy. As I gotten older, I think they made me just things that didn't really matter why I wasn't happy. But I remember leaving WPI and going to a rowing center in Connecticut, and it's called GMS, G-Man Systems Rowing Center. And I was living in the office trailer on the site, and I thought to myself, well, this is kind of like a fork in the road. Like, you don't have an engineering job, you're not at a rowing like a big rowing camp, like a US rowing camp. You're just training. So you got to figure out what you're doing for life. So I remember applying to Berkeley, MIT, and Stanford. And I said, if I get into one of these PhD programs, which is like, there's no way I'm going to get into one, but I'm going to try anyway. If I get into one, I'll keep rowing and get a PhD, because that's the only way I could think about or think of to be able to row at a high level and still be an engineer without giving up engineering, which would have been very stupid of me to do because I was obviously good at engineering. And lo and behold, I got into Berkeley. Had I not gotten to Berkeley, I'd be done then too. So it just kind of worked out that way. I almost didn't have a spot at the rowing camp. I remember showing up a few times and I was a nobody at California Rowing Club in Oakland, which was one of the US training centers. I remember showing up a few times and I was a nobody there. And just through some determination and thinking, there's no way I'm going to let these people beat me, because like I'll never get a shot again. Like, I'm just a guy from New Jersey, and now I'm training with all these great people. And I think through that, recognizing the opportunity that I had and I would never have this again, kind of pushed me to do as good as I could do in the sport.
I want to dive also a little bit into the engineering because you mentioned you were really good at it early on. I find it's unusual to have those two strong drives that seem to be different, but maybe also complementary. So I'm kind of wondering that engineering, how did you uncover that is what you wanted to do early on? And was there actually a path where the rowing helped you solve some of the engineering problem, or was like a different part of your brain and skill set to help you continue going with things on the engineering side?
So I think a lot of this experience is I didn't have any other good options. It was kind of where I wound up. And it just so happens that the things I was good at and I liked doing were also really smart things to do. So when I was younger, I was obviously good at building things. And then like these Legos, projects in the backyard. My dad was a construction worker or had a small construction business when I was young. So I kind of wanted to do the kind of building thing when I was young. That's what I was exposed to. And then as I had to progress through school, I got better and better at school and better at mathematics and physics. And it turns out I was pretty good at physics. And I think a lot of that, why I got so good at it was, perhaps natural aptitude, but also I didn't have many friends. I had nothing else to do with my time. And I wasn't really a computer scientist, so I didn't really spend a lot of time on computer coding. It's just not what I enjoyed doing. I like building physical things. So I got really good at school and engineering young, and then I had a leg up in the competition, and so I just kept going with it. And when I got to WPI, it became more obvious that I was good at engineering and specifically mechanical engineering. But I also think that like I had a chip on my shoulder at that point. Like I wanted to prove that I was worth something. Like I kind of had the ambition and reason to go do so well at school.
I see, I guess, the through line, the drive, and being able to commit the time and hours needed. And that seem to be actually the same path, whether it's engineering and building things and making things work, or whether it's rowing, which seems to be, again, the way you describe it, just brute force and being able to suffer through pain to go as fast and push your, seems like VO2 max all the way to handle as much pain as you can within the time of the race.
Yeah. And, if you talk to high level rowers, we're kind of all similar in that respect. Like if you want to be good at rowing, you got to be able to deal with the pain. You can't get around it. And also, and surprisingly, or maybe not surprisingly, a lot of rowers are also pretty intelligent. And I think, well, two things. I think that because a lot of rowers come from high prestige schools, you get a lot of smart people. Like you have to be pretty smart to get into a Harvard or Yale or Brown, Cal, UW. So you get a high concentration of smart people in the sport. But I also think that having some intelligence and you need to have a lot of discipline, determination. You need to be good at doing repetitive tasks well, consistently. And these are all traits that are also common in successful people. So you kind of get a high concentration of people who will achieve future success in rowing as well.
You mentioned you can learn to be a good rower in 1 month. I actually find rowing to be quite difficult. I had obviously only learned rowing in CrossFit, so I had people show me a little bit the technique and how you pull and kind of the rhythm, which is, I'm sure, nothing comparing to the real rower on the water. I find there's probably much more just balancing. I feel like if I tried that, I would probably flip over right away. Going back into the technique and just to break it down, you shared a little bit about the mental aspect, but on the physical side, what else goes into it?
It's a really simple sport. The objective is to go from point A to point B faster than everyone else. That's it. Very easy, in principle, anyway. And then to do that, there are two things you need to do. When your oar is in the water, you need to pull as hard as you can to make the boat go as fast as it can. And when your oar is not in the water, you need to not slow the boat down. That's really all the sport is. So, and if you're in a team boat, you need to do that together, so that the masses are moving at the same time in the same place in the boat. And then there's only a few ways to do that. So if you try a few things early on, you'll figure out what motions move a boat fast and what don't. And it took us a little bit in history. It took us a while to figure out what the optimal rowing stroke is, which is kind of you drive the legs first, then you swing the back, and then the arms are last. You go through the strongest to least strong muscle groups. And you're kind of trying to put the maximum force in the oar through the stroke to propel the boat without what they call ripping water. So that's moving the oar through the water without moving the boat forward. So you can kind of figure that out, one, by watching someone else do it. And then by feeling the oar in your hands and the pressure on the footboard, which is where your feet go. And if you're kind of looking for it and focused on the right thing, you're going to figure it out pretty quick. If you're focused on things that don't matter, like getting a good workout in as opposed to moving the boat forward, or looking good for the coach instead of moving the boat forward, you're not going to go very fast. So having the right goal in mind is going to help you move the boat quickly and towards the finish line faster.
But actually, what you had described to me now seems like maybe the mechanical engineer or physics and mathematics and being able to understand how just a smidgen of a different form either helps you go faster or slower is probably quite important. And being able to observe what is slowing you down or what's speeding you up, and probably like a small different angle in your seating or positioning probably makes it sometimes big difference whether you win or lose.
Yeah, that's what I said. You can learn 90% in a month. The 10% is going to take you years. So that's why people generally stop rowing. It's because you get a huge advancement in the sport really quickly, and then it's a giant plateau, both technique wise and um, physically wise. So you have to train your body for, unless you're already trained for that type of sport, it's going to take you 4 years before you're anywhere even close to being ready to go row well. By the time you transform your body into that person you need to be, and then learning all those little tiny things, you're constantly making these minute changes in your technique so that you can move the boat faster. And then every time you bring a crew together, you all need to come together and move the same way. And everybody's body is a little bit different. Like I have a really short torso, so I had to move my body in kind of strange ways to match other people. And I would have to change how I moved with different people to make the boat go fast. And I think one of my strengths I had when I rowed, because I'm not a physical outlier in rowing. Like I'm average to somewhat smaller in height. I was pretty fast on the rowing machine, but not crazy fast. I was maybe top half, but not like the best on the rowing machine. I think what gave me a shot at doing well was that I was solely focused. I was going to do whatever I could do to help the people on the boat move the boat as fast as possible. And it takes these little tiny small movements of your body and changes to get that to happen. And I was solely focused on every stroke being as efficient as possible. Every stroke is a new opportunity to make the boat go fast. If you mess up the stroke before, that's fine. You get another shot next stroke. Every second is a new second.
That's interesting. Just the speed of repetition. I actually love that. I mean, it's also true probably in any sport, even in tennis. Every point is a new point, and having that mindset. I guess the difference here is also being in tune and observing other people on the boat and just moving synchronously. And to a point that takes a while. How do you create the best team? Because again, you made it all the way to the US 2012 World Championship. You also competed in 2015 in the Senior World Championship. So, what is that process and preparation? I'm guessing you have to have that team training. How much do you all train together to get that synchronization in?
Yeah. Well, I should say I didn't make the Olympics, so I'm not like the best. Obviously, I didn't get the ultimate goal. It's like any team. A lot of it is trusting your teammates. If you don't have that trust, you're not going to make it. Especially in a rowing boat. Like if you don't move together and one person wants to be the ego one and be right all the time, the boat's not going to go anywhere. You're going to go slow. So you got to be willing to work together to move the boat. And you have to understand everybody's personalities from little things like, this person needs to do the stretch in the morning or they're going to be all kinds of messed up. Or, hey, this person had a fight with the girlfriend last week. That's a problem. That's going to mess the boat up. And those little things matter when you get to be at the top level. Stability, because the rowing is such a repetitive sport, stability matters. Anything that's going to screw anything up is going to be unplanned that is harder to deal with. There's enough things that are hard to deal with, like that little wake in the water that, if you just look at it, you're not in a rowing boat, it's like, oh, there's a little ripple. You hit that with your oar and you've got a problem. So there's plenty of unplanned things to worry about. So keeping the team, in the right mindset and moving together correctly is pretty key to winning a rowing race.
How did you all learn to communicate then? Is there like a checkpoint before you get to the boat, or do you all get to know each other so well so you can kind of tell who needs more or less communication or how to support each other?
Yeah, you spend a lot of time with your boatmates. So like you row a lot. You row millions of meters a year, maybe 2, 3, 4 million meters a year in a to get ready to row. That's a lot of time. You're gonna spend at least 2 hours a day together, if not more, probably four. If you get older in a sport, you actually spend less time together because you have other things in your life going on. So you'll have other things to do. You do kind of erg workouts on your own and gym workouts on your own, but you definitely row together a lot. So you're getting to know your teammates is mostly done by just spending a lot of time together. And then you gotta have just blind trust. You can't really be thinking this person is going to screw me over every day. When you get in the boat, your ego's gone. You see, it's a lot of younger athletes. So they get into an eight and they want to beat everyone in their own boat. and they want to show that they're the best. And it's like you miss the opportunity to do that if that was your goal. Your opportunity to do that is in the wintertime when you're always on the rowing machine. When you get in the boat, you're no longer trying to beat everyone in your boat. You are trying to beat the other boat. That is the goal. So you all need to work together to beat the other boat.
Yeah, and centering that mindset just around that. I love that kind of selflessness. It seems like you all just in it together and trying to figure out how to play the strategy and be most effective and efficient. Moving on to your quite technical engineering, mechanical engineering roles that you have had for quite a while, how do you see those skills translate to your profession now and being good at what you do, which you're building with a team, AI driven robots now? Actually, that's what's kind of the world is heading towards. I've been recently watching even the Elon Musk shareholder conference where he released his Optimus robot stating that robots will take over the world. So I'm curious, maybe we can dive later on into that area of what you see. But from skill set perspective, how do you see those rowing skills complemented your mechanical engineering and leadership in that area?
There's a few things that cross over. There's a few things that I wish cross over and don't. Things that do cross over in engineering, especially hardware engineering, things don't happen immediately. It takes time. If you want to develop, let's just pick a car because everybody knows what a car is. Cars have a 4-year development cycle. It takes 4 years to get from, somebody in an executive room, 4 years minimum, but most of the time longer than 4 years. 4 years minimum for someone in an executive boardroom to say, hey, I want a car that does for this class of people, to actually having a car you can go buy. And that car you can go buy, if it's the first of that model, it's not going to be that great. There's going to be something wrong with it. And it's going to take even more time to make it really good. So you need to stick with that for a long time and deal with all the ups and downs. So I think a lot of the rowing kind of translates to that, because it's not like, another sport. I don't know. Let's pick another sport, baseball. I forgot how many games there are a year in baseball, but it's a lot of games. And in rowing, there's not that. There's like one race a year to World Championships. You might not even go to the World Championships. You might only go to the Olympics. So you have 4 years of almost no real joy, just misery. And then you get one shot that's 6 minutes to actually prove that all the work you did over 4 years, those millions and millions of meters you rode, actually meant anything. And that's a lot of what engineering is. So you toil away on your CAD machine and with your prototypes and your development builds to release your product to the world, say, here it is. And no one sees any of that work you did. They just care about that one little time to show the product off.
I love that analogy. I guess if we can dive a little bit into the robotics too and AI, and I guess the physical AI, that's been a theme that even Jensen, founder and CEO of NVIDIA, has been talking about. I'm just looking at your website. Dexterity is physical AI powered industrial superhumanoids for large enterprises. The way I understand it from your website, feel free to correct me, it kind of helps with palletizing or robots for imagine an UPS or FedEx trucks loading, unloading boxes, etc. How do you describe for listeners, anybody who's thinking about mechanical engineering and kind of the future where it's heading, what would be your guidance from your perspective?
Okay, so let's break it down to a few things. So we got what I do at my day job and what they're doing. And I should mention, I'm just an engineer there. I'm not a company officer. So the amount of things I'm going to be able to say is pretty limited. And then we have where I see physical AI going in the future, or robotics. And then we have, if I was giving a STEM talk, what I would tell young engineers to do. Which one do you want to tackle first?
Thank you for breaking it down. I love it. Take whichever you want, whichever order, John.
All right, let's take the young engineer first, because I actually like doing STEM talks a lot. When you get to college, let's just say you identify you want to be an engineer. I'm lucky in that I knew what kind of engineer I wanted to be fairly early, and I was right about it. I could have been wrong. I would have had to switch careers or switch engineering fields. Well, let's say you've correctly identified you're an engineer, or you think you have. So you get to your first real core class in your discipline. Let's for mechanical engineering is stress and statics. If you don't like stress and statics, you're not going to be a mechanical engineer. Go find a different engineering field. You're in the wrong one. And it's fine to say that, like totally fine. And maybe it's a little too simplistic. There are other kind of branches of mechanical engineering you can get into. But the principle is if you don't like your like first core classes, go find one you do like. If you don't like engineering process solving, you're not an engineer. That's okay. There's plenty of other things to do in life. You don't have to be an engineer. Go find something you like doing. If you don't like it, you're not going to succeed in whatever you're doing. And if you're of the mindset, I want to be in business, well, that's great. You need to find what you're in the business of. Are you in the business of healthcare, in the business of engineering? So you need some core skills to actually get good at business, whatever business you're in. So liking what is a key core of your profession is important. Then specifically for mechanical engineers, kind of the time of pure mechanical engineering, like I'm going to make gears or whatever, is kind of over. Mechanical engineering is a really broad field. So be really open to learning or at least understanding other types of engineering if you want to succeed. You need to learn some coding, whether you like it or not. Sorry, you gotta learn how to code. You need to learn some electrical engineering, especially wire harness routing, because you're going to be doing that whether you like it or not. And no one likes wire harness routing, by the way, but you still have to do it. You got to learn materials. Mechanical engineers need to be the broadest of all engineers. You're kind of the system integrators, putting everything together into the physical product you make. That would be the advice I give to young engineers and mechanical engineers specifically.
And then moving from there into even just some of the prediction, or if you can share a little bit about Dexterity and what do you do?
At Dexterity, we have a small engineering team, but we're a fairly experienced engineering team. So it's been fun to work with a lot of smart people who, as a startup too, so you need to be fairly quick and good what you do in Agile. So it's a fun environment to work in. It's very fun to be in an environment. And it was fun in rowing too. If you're with everybody having a mission, this is the thing I wish was more in corporate America. In rowing, there's a singular mission. Everyone's aligned with the mission. If you're not, you fail because you lost the mission. In corporate America, it's easier to get through without being aligned on a singular mission and still succeed. Or you succeed, but not as well as you could have. So I wish there was more of that mindset in corporate America. But going back to Dexterity, with a small team that I have there, it's been a lot of fun. I've really enjoyed working with people. They're engineering focused. There's less kind of like just trying to move the corporate ladder, which you typically get in startups. You get less people just trying to climb ladders. So it's been a good time there with Dexterity. And I work on mostly mechanical things, but I also do a little bit of electrical work. And like I said, you need to be good at all engineering at this point. You can't just be good at one thing unless, well, I shouldn't say that. You'll know if you're the type of person who wants to be good at one thing. And if you are, your best path is going to be going all the way to get a PhD and being the world's expert on anything. But those people are pretty rare. And if you're one of those people, you'll find out you'll know you're one of those people.
I guess people do know naturally whether they like the broader view or they like to focus on a specific expertise. I mean, for you, it seems the way you tell the story, it seems almost too simple. Like you knew rowing, you were good at it, you knew engineering and mechanical engineering. So you sort of went that path and you put all your focus and hard work into kind of those categories to become as good as you can be in those fields. But was there a specific moment, if you reflect, that you were pondering whether this is the right path or not, or how do you really recognize that where you're putting your time and effort is the right path or right thing?
Yeah, it's a good Mark Cuban quote. Nobody quits anything they're good at. That's true. If you find you're good at something and you have a competitive advantage, you're not going to stop unless there's some other reason, like it's detrimental to your health or whatever. But I was good at it and I liked it enough that I kept doing it. And I think that's the people who get good at one thing. I think that's a lot of what they find is that they are gifted in a very specific thing and they really like it. And their personality is that I want to be the best at this thing. And that will show up, in their mid 20s, they'll find out. that that's them pretty quickly. I'm not one of those people. I have tons of things that I like more than other things. And some of those things I don't get to do a lot. Like I love material science. I don't get to do material science very often, but it's one thing that I love to do. I have a pretty strong depth in that field of engineering. And like also, just because you like something doesn't mean you should do it all the time. Because if you're not having any success in it in the world, then it's probably not what you should be doing. Or you should find something else to do for your career, and maybe that's just a hobby for you.
Another Mark Cuban quote, actually, that I remember him saying is follow the effort, not your passion. Because he always say he loves basketball, but even if he put all of his time into basketball, he would never be best at it from his view. So, what is it that you're willing to put your effort in every day on a repetitive day over and over, and that ultimately will help you be great? Because, yeah, in life, there's a lot of repetition, and we often got to get up and do the things over and over, even if we don't feel like it, which I think is, again, the synonym or what I'm hearing from your journey. It's the same, whether it's a rowing or mechanical engineering, you put a lot of time and effort to build something that ultimately, hopefully, becomes a success.
Like everybody believes that everybody gets the same opportunities. That's not true. You don't. I'm sorry. If you get an opportunity that's better and you can win at it, take it. I remember being one of the, like, I was so unhappy. I didn't know I was so unhappy because I didn't know any different, but I was pretty unhappy in my childhood because I didn't have a whole lot of friends. I felt like I was bullied a lot. I went from that to being one of the more popular kids in college in a day, which is a very strange experience. And that was because I saw an opportunity and seized it, right? I just got lucky. And that might happen to you. And if you get the opportunity, take it. The kind of thought that you can do anything out there is a little far fetched. You can't. Not everybody gets the same opportunities.
Seizing the opportunities, seizing the moments. Speaking about opportunities and where things are heading now, I'm curious, since you're working now with autonomous robots or creating autonomous robots, where do you see the world heading if you think AI or even the physical AI that's now being talked about a lot? How does that connect to your mechanical engineering skill set and actually helping robots be autonomous and perform their own actions?
It's kind of a cool time, or it's not kind of, it is a cool time. So we kind of had this, kind of step change, or maybe finally, people don't believe something until they actually see it. So, okay, here is something which is AI, and look, it's real. It does things. We can make it do some stuff. And then once people see this, their imagination goes off and they say, oh, we can do all these other things because now I saw this one thing. So we're at this time where that's happening. So everybody's getting really excited, and there's kind of a lot of expectations. Some of them are unrealistic, some are realistic. We'll find out as the future unfolds what we can actually do, what we can't do, and at what timeline. Obviously, now the spotlight is on the AI software stuff, and all the other engineers. The spotlight's not on us, but we're exceptionally key to making this all happen in the real world. If you don't have good hardware, you can't bring all this stuff to reality. It's just in a computer code. So the other engineers play a really important role in making this stuff happen for the future. Without us, you wouldn't have anything. You just have ideas and imaginations, which aren't real products. Real products are things you can hold and touch. Well, real physical products are things you can hold and touch. They aren't renders on a machine or anything.
What I'm hearing you, I don't know if this is accurate, feel free to correct me. It's that the interoperability and the connection between all the different parts of the stack, whether it's hardware, software, obviously AI, is perhaps becoming even more important now than before to work in parallel and synonym to make the machine do whatever kind of the AI and the physical AI enables you to do. Is that accurate?
That's right. We just talk generic, not related to anything I've ever made. But let's say you have a widget and it's doing something and it's controlled with some software. If the mechanical engineers design or the physical engineers design the product before the software knows what they're going to do, you may not have the sensors on it that you need to get the job done. And then you're going to have to add them later. And if software tells the hardware engineers, just make it, fine, we'll fix it in code, that never goes well. So you need good hardware if you want to make a real product. Like, let's just say you had a home robot, and in this home, it gets to be 100 degrees Fahrenheit, but you select hardware that only goes to 80 degrees Fahrenheit. Well, guess what? Then you're not going to be able to run your robot when it's over 80 degrees Fahrenheit, and then your customer's going to be unhappy. So you need to have physical hardware that's going to be able to meet your requirements for your software team and vice versa. And if you don't talk together, you're not going to operate as a team together. And then everybody's just going to be mad at each other and you're not going to do very well.
Now that you mentioned robots, home robots, I'm curious about your own perspective. I'm personally a big fan of robots. I've been following 2 different companies. One is in your backyard. Obviously, there's a lot of companies in your backyard in the SF Area. 1X Technologies. I found them actually listening to the NVIDIA AI podcast, and they recently released, you can put $200 deposit and then order your own robot, which costs either $20,000 all in, or I think they have 400 or so subscription, and you have to kind of train it on what do you want to do. And I've been like so pondering, do I order one or do I ship one for my mom? Obviously it's super expensive, so there's going to be very limited amount, I'm guessing, of people who will order the first version, and also how useful it will actually be and how much you can train it. But curious, since you're working around the robotics, would you order one if it was affordable yourself? And do you think also the risk of the AGI robots taking over the world, that's another thing that when I talk to people that are quite heavy in the field, often bring up as one of the first things they have top of mind. How do you look at those things?
Yeah, so there's 2 concepts. I will briefly touch on robotics, so I won't get into anything specific because I'm in the industry. But just generally, they're cool. They're really cool. If you have the right expectations and what they can do, like they're not going to change your life right away, but they're fun and cool. So if you want a really cool toy to have, and they're going to be toys for a little bit, like we have to train them and all things. I don't know how long it's going to last. I can't tell you that, but they're cool. Go buy one if you want it. Just don't expect it to change your life right away. Unless changing your life is smiling, and then you might smile a whole lot. So please go get one. And that goes for anything. Like if it's new technology, it's always exciting. It's always fun. If you have realistic expectations for new technology, it's great to have in your life. It helps the entire world move forward. As a society, we're humans are unique and we use tools to live. Like we're one of the only creatures out there who uses tools. Without all these tools, we would not have the society we have today. So unless we all kind of move forward in direction and together put up with the ups and downs of it, we don't advance as a society. So that's that. And then the second one was taking people's jobs away. I think software is going through this right now where everyone's worried about them losing their jobs in coding. Like to me as a mechanical engineer, I saw this coming because we already had this twice. We had CNC machines come out that put thousands of machinists out of work, or they had to adapt new skills. They had to learn how to program machines. And if you didn't, you were out of a job. If you weren't willing to adapt and accept the direction the world was going, by the way, that's not just like going with the flow and not saying anything. Like if you see a problem with something, like if you see the industry moving direction is creating unsafe technology that's going to hurt people, you need to say something. And there used to be some conversations to move it in the correct direction so that things are safe and they do what you want to do. But if you don't adapt, you're going to be left behind. So we had 2 instances of this happening. One was CNC machines in manufacturing. The next was computer-assisted drafting. That put a lot of drafters out of a job unless they're willing to learn how to use AutoCAD. So we already have these 2 giant leaps in mechanical engineering, and we're seeing one of these happen in software right now. So unless people are going to be able to adapt to this, and it's also an opportunity to get better. You're reducing the amount of mundane, non-value adding tasks to focus on more value adding tasks. So focus less on doing the mundane things and more on the exciting things that are like new frontiers. That's where you want to be. That isn't to say you shouldn't do anything mundane, because you need to do both if you want to do well. You can't just do the fun things. Life is mostly unfun.
I agree. Actually, that's often I get a comment from clients or friends I talk to about AI or the resistance of AI. I actually think we tend to lean towards even just adopting and testing these AI tools to use them on things that we actually hate to do. that creates more time for actually the things that you enjoy doing. So if we just all hone in on that. When I think of robots and having a robot, the first thing that comes to mind, I hate cleaning shower. That's the one thing. I'll clean other parts of the house, but if I only had a robot that would clean the shower every day or every other day, I think that sounds pretty fun. And yeah, the mundane things. I shared the Elon Musk shareholder meeting this morning, so it's fresh top of mind. But I was checking his Tesla Optimus. The first two sentences he has here, it's general purpose bipedal autonomous humanoid robot capable of performing unsafe, repetitive, and boring tasks. So actually exactly what we humans don't want to be doing or is too risky to do, or the things that we don't enjoy.
Yeah, you hit it here and everything. That's what technology does. Technology allows you to live a better life. The reason is you do technology. If you're not in it for those things, I don't know what you're doing.
Question about the AGI or artificial general intelligence that is quite often tied to robotics, or people often think, well, I'm going to have a robot in my house. Is it going to take over or do things that is not programmed to do and start thinking on its own? And am I going to be in danger? How do you assess that world, John, or that risk?
I mean, there's always risks, and we put up with them. Like before the automobile was invented, no one got into 100-mile-an-hour crashes. Now we do. The world moves on. You can't live in a bubble. That's my general thought of it. But it also takes people having conversations and discussing on safe ways to do things. It's very fine to create new risk in life. Go for it. We do it all the time. But you better understand the risk you're creating, and you better make it so that everybody can accept that risk. And just because one person accepts a risk doesn't mean another person is going to accept the risk that if person A accepts a risk, and by accepting their risk, they're increasing the risk of person B. Like that is a potential issue there. And that's where most of the problems we have in society lie, is one group accepting more risk than the other group, because generally people's main concern is their personal safety. So if some ways choices affect their personal safety, they get mad.
Actually, there is a good example. We have been seeing this is with the autonomous self-driving cars. I personally have Tesla on a software 12, so I'm waiting. I actually bought the car earlier, so it's not in the top self-driving 14. I know some of my friends have the version 14 software that seems to be doing fantastic. But that's another thing that I feel like I always get angry at the car when there's like that one split of a second you want to check your phone. And that's when the car should drive itself, because that is where my focus is limited. And Elon actually literally talked about it. Everybody just wants to drive a car and check their phones. That seems to be the super use case for it, which I concur with. But yeah, that's when the car should be paying 100% attention. Instead, they reverse engineer the software because other people took advantage of it. And so I cannot now be on autopilot and check my phone, which is actually the natural things that it should be able to do when I'm less focused.
Like, this is a saying category of people don't use directionals on the highway, which infuriates me. It's like directionals are not for you; they're for everyone else around you. You're putting people else at danger. Please use your directionals. Same thing goes for listening to technology. Like, be responsible. You can spoil it for everyone else if you mess it up.
Yeah. On the autonomous cars, because you live at the intersection of new technology. Curious, do you have a regular car or do you have one of those smart self-driving cars?
No, I have the opposite of a Tesla. I have a 2003 gas burning pickup truck that gets like 12 miles to the gallon. That's what I like. I have that, and I have a motorcycle. Yeah, I think having a fancy, cool, smart car would be nice. I guess like my truck. I'm also not a very showy person. Like, I don't care what I drive, or I don't care what anybody thinks about me.
I guess the mechanical engineering goes with more the real trucks, perhaps, like creating things that last quite a bit. But I was wondering which way you're leaning, given your field, and what do you do?
I was a battery technical lead at an electric vehicle company once. Like, I was in charge of battery stuff, but I love engines because I'm a mechanical engineer. It's a hobby thing. I like engines.
Yeah, makes sense. So, given where the world is heading, obviously a lot of robotics, AI, physical AI, the omniverse thing that Jensen always talks about, and reflecting on your journey, how would you help younger people guide which way to go now? There's a lot of questions that seem to pop up, like what do kids study? The job markets may be changing. I mean, you are still in an interesting spot in profession. How do you distill of what might be ahead and what to focus on?
Yeah, there's a Warren Buffett quote that's like he would give up 1 year of his life to know what's going to happen in the next 10 years. We're an amazing society. We're going to generate all these new cool things. So be excited about it. And then you need to position yourself in a way that's going to let you do that. And it might take some time because like not everybody gets the same opportunities, like I said, but find something that you like to do and are good at and has an economic, benefit to it. If you have a passion for medicine, go into medicine and also be really excited about new tech because it's going to come whether you like it or not. So get with the program and use new technology.
Yeah. Obviously, I'm a fan. I think technology is awesome because it allows us to solve some of the hardest challenges. Yeah, I agree. Any predictions for where the world is heading? Like, if you think of what's ahead, what would you want to inspire people to be doing more of or less of?
I've learned not to predict things. I'm really bad at it. Like I can say more teamwork, man. Like, so I didn't make the Olympics and this is a long story, but, and no sculling boats from the United States in 2016 made the Olympics. And looking back on it, it was all egos from different groups and people because everybody wanted their own team to win. And it was detrimental to to the success of the United States in sculling in the 2016 Olympics. So I think from that experience, I'd say, align on a goal and then work together to achieve the goal and define the competition correctly. If you have misidentified competition, you're going to have just infighting and you're not going to beat the competition. You're going to lose.
How do you correctly observe the competition though in the game? It seems like there is a deeper learning if like understanding what's going on around you and how to even play tactically correctly.
That's where the real fun stuff is, right? It's like what strategy your team is going to use to beat the competition. That's the stuff that gets people really excited. What tech you're going to align on, what IP you're going to file, where you're going to do business, who you're going to hire. That's the exciting things. Yeah, that's everybody's secret sauce, and that's where you succeed and not succeed. All these little decisions you make end up helping you succeed or not succeed. And in rowing, your Olympic dreams can be over in a second from one mistake. In business, you get more time. It's usually not like that. So you get to make some mistakes and still win. Like in rowing, if you mess up one of those 220 strokes, you're done at the games. Like that's just it. I'm sure there has been a boat that had a major mess up during the games and still won, but I can't think of any off the top of my head.
Yeah, because you're also competing against the best of the best. And so one mistake within that short amount of time really counts. Yeah. Perfection is rewarded in those races. Yes.
Yeah. And in business, like, if you get to be in a field that's been really well defined and out there for a while, that's what it is. When you have two players going head to head and there's only two of them, they're the best of the best. And there's real money to be had, which is success. Like life is a competition. You better be on your A game.
Yeah, that's true. Anything else before we close out, John? Anything that's top of mind, rowing, mechanical engineering, AI, robotics, technology, insights? What do you want to share with the world?
I think like just broadly speaking, one thing I like to put out is, mentioned at the beginning, is the single biggest thing I like people to take away from my short life so far that I think has been cool, but you may not. You can have your own opinion on my life. I never thought that I'd have the opportunity to get a PhD from UC Berkeley and be on the USA rowing team. They were never in the cards for me. The future is it's as bright as you want it to be. So just make sure you're looking out for opportunities as they come. And if you get one, take it. You might not get another shot. And smile. Life's good.
I love it. Thank you for that. And with your permission, I'll add your LinkedIn profile to the episode notes if anybody wants to reach out or connect so they can easily click and find you. Or is there any other best way to follow you and connect?
I'm pretty anti social media. I only have LinkedIn. Actually, I think I have profiles, but I don't use them on the other sites. So LinkedIn is the best way to connect with me. And I'll do the best I can to get back to people with their questions.
Excellent. Thank you. And yeah, appreciate your time and hope to be in touch. Maybe we'll meet in the Bay Area or in Austin if you have a trip here at some point in the future in person.